What are computer systems and robots that can think and work like humans made from? That's what artificial intelligence is about. Today, I'm going to talk about that. If we take artificial intelligence, or AI simply, its meaning is the ability to imagine like a human, the ability to think independently, the ability to find an answer to a question independently, and so on. It's the ability to recreate independent intelligence capabilities, intellectual capabilities, within a machine, especially a computer. Before doing this, let's look at two small examples to understand how a human mind and a computer work. I'm giving a math problem to solve. 274 multiplied by 357. I'm giving this math problem to a computer and to an average person. Usually it takes a computer a 10 millionth of a second to solve this math problem. Some take even less time. But it usually takes an average person about 30 seconds to solve such a math problem. The most important thing we can understand from this is that, especially in terms of computational ability, a computer is far ahead of an average human mind. But now, let's challenge a computer and a human to solve a more complex problem, a problem that requires more intelligence. If we ask them to identify the cat images in this image separately, who do you think has the ability, the computer or the human? A human can do this very quickly, but a computer can never do this at once. The reason for this is that more than just mathematical ability or computational power, intelligence is needed to solve such a problem. You might think that identifying such an animal is a very simple thing, but in reality, this requires a very complex mental process. Tell me, what is your method of identifying a dog as a dog? We can't give an answer at once because actually millions of neurons in the mind connect, and the information provided by that connection is what animal recognition is. It's a very complex process. You can understand that this is a cat in every instance. Even if you've never seen these pictures before, you still understand that there's a dog as soon as you see these images. Sometimes you don't even need to see the dog's face. So this is what an intelligence process or an intellectual process is. It's not logical. It's not determined by creating a set of arguments and considering them. Instead, this intellectual process is an analysis based on our past knowledge and experiences. It's very different from how a normal computer works. A computer is a device made up of a huge number of electronic circuits. A computer works based on the numbers 0 and 1. A computer knows these zeros and ones by whether there is an electrical potential in a circuit. That is, if there is an electrical potential in the circuit, the computer knows that the number 1 has been received. If there is no electrical potential, the circuit knows that the number 0 has been received. In this way, these numbers 0 and 1 can be arranged in a logical way to make circuits. Here are two circuits, AND and OR, made in that way. For the final value of the AND circuit to be 1, both inputs A and B must be 1. For the final output of the OR circuit to be 1, it is sufficient for one of the values A or B to be 1. This is an example of the most basic logical capability in a circuit. So, millions of such logical circuits, or logic circuits, come together to give a computer its logical capability. This logic is actually not determined by a circuit, it's actually determined by another human, whom we call a computer programmer. What does a programmer do? He creates these logical circuits in a way that a computer can read. Then what does the computer do? When it is given some data, or some information, it analyzes and synthesizes that information according to these logical circuits and turns it into useful information. This is only a logical process. That logical process was also done by a human. So the computer hasn't thought and done anything. We can't classify it as an intelligence process. It's a much lower level than an intelligence process. When we take a computer, it's actually just a large-scale calculator. Only a logical process takes place within it, not an intelligence process. But the human imagination process, or the intelligence process, is much more complex. It happens especially according to the way neurons are arranged in the brain. We know that there are more neurons in our brain than stars in the sky. Each of these neurons connects to each other in a special way. According to the way these connections are made, the way information travels changes. This is how our brain thinks, explores information, and builds old memories. Many complex things like this are done by our mind. Actually, the intelligence process is such a result. Let's see how it happens, how we think, or how we operate. Our nervous system mainly controls us. We know that our nervous system, especially related to the brain, is made up of nerve cells. These nerve cells exchange information with each other through small electrical impulses that travel through them. Also, these nerves have the ability to connect with each other. A nerve can connect with several other nerves. Also, when these electrical impulses travel between these nerves, they travel through these nodes, or what we call synapses. Through these, the electrical impulses travel to several nerves. In this way, nerves are connected to each other, forming neural networks. All the things we know are stored in these neural networks. There is a neural network in our brain for everything we have learned, seen and read. For example, if we take the concept of a cat, there is a corresponding neural network. When a child sees a cat for the first time in their life, they don't have the corresponding neurons. But as soon as they see it, as they touch the cat, as they interact with the cat, according to the sensations they get from looking at it, neurons start to form in their mind. These neurons are repeatedly formed into a neural network. When they see the animal again and again, this network becomes stronger. That's how a person puts the concept of a cat into their mind. That is, understands about the animal called a dog. Okay, let's talk about this in a little more detail. When a person understands a concept, that concept is often recorded in our minds in different parts. That is, if we take our familiar example, neurons are formed in the child's mind, according to the arrangement of the animal's ears, the position of the eyes, the position of the nose, the tail, and so on, and several other things. These networks are reformed for larger parts, especially the dog's ear, then its eyes and nose. The colour is also formed, and a concept is built up. This is what we call the dog's face. This is also actually a lot of neurons formed in our minds. In this way, all the concepts of how the cat's body is formed, how the dog's legs are formed, how the dog moves, start working in our heads. All of this is done by building neural networks. As soon as we see a dog, all these neurons start to form in our minds. So as soon as the child sees a dog, all these neurons start to fire at once. When they fire, we get the concept, this is a dog. Another important aspect of an intelligent process is the ability to learn. Now, we see different types of dogs, but the child may have seen only one type of dog at first. But as they go further in life, when they encounter different animals, the neural network in their mind about the dog they talked about earlier grows systematically. So different animals like this are connected to the same neural network, and they get the ability to analyse with the idea of a dog. Also, they can learn from mistakes. For example, let's say this child went to a zoo. There, they saw a tiger, and they might be fooled at first into thinking that the tiger is also a dog. We know that many things like this happen to children. Then someone tells them, "Son, this is a tiger, not a dog." What happens? The neural network is formed in such a way that it can process that information too. So in this way, the learning process takes place continuously, and a concept is built up in our minds. So by repeatedly doing this process, what happens is that this concept is very well formed in our minds. As a result of this learning process, as a result of this neural network, even if all the parts of an animal, like a dog, are not seen, sometimes only the face is seen, and we can build the concept of a dog just by connecting to that network. That is, to put it simply, if we see only a cat's face or only a cat's tail, we can clearly say, this is a cat. So you can clearly see that this method is different from the way a normal computer works. Also, this mental method has another concept, which we call situational bias. Let's say we have a dog at home. Now, the dog's face is extremely important for identification, more so than its tail or fur colour. So more weight can be applied to the dog's face. We understood that point, because we know that when identifying any animal, we give more weight to its face. We give more bias to the face than to its colour. Often this can vary, but generally, the importance of weighting is the same. So the output of the function we take in this way is a value between 0 and 1. Now, for example, if we can accurately confirm an animal like this, then the function should output a probability of 1. Or we can set a threshold for this function. If something comes from the system that is definitely like a cat, then the probability is definitely 0. But any system has an intermediate state, a state where it cannot understand something. We also have that. Look at this example. We can't say at once whether this is a cat or a dog. We can only give a specific probability for that, or a likelihood. So we can write the mathematical system we found in that way as a program. Then what do? We can train that program. We use images like this for that. Now, if we take the example we talked about earlier, we can give the program images of various animals, dogs. Along with that, we input the variables we talked about earlier. We input the head size, colour, and so on, and also confirm that the image is a dog. We can give thousands of these images to train the system. So when we repeatedly give the system images of cats, or images of animals that are not dogs, and the corresponding inputs, along with the output, we can optimize the weight values, or we can find the most suitable values mathematically. Then after we find the mathematical values in this way, what do? After we optimize those values to a suitable level, after we find a successful result, we can put it into practical operation. That is, we can give any animal image to the computer program and ask what animal it is. Then, because the mathematical model we talked about earlier has been optimized, what happens now? When we give an image, the computer program gives a good value, a good probability, whether it's a dog or not. So what actually happens here is that without following any logic, the computer program works based on the information given, understanding what we learned earlier. So this is the basic stage of artificial intelligence. We call this a neural network because these systems work in our minds, in our brains, in the same way. Artificial intelligence is not really a new thing to us. Many devices we use already have a significant level of intelligence. Also, many companies and various organizations use these. The best examples are our Google Assistant or the Siri app on our Apple iPhones and Amazon Alexa. These devices actually have a level of artificial intelligence. That is, they can understand how you operate and give you an answer or help accordingly. These are systems that can help us. Also, AI is used in many fields, especially in military, healthcare, hotels, and road systems. Also, an important aspect of artificial intelligence is that we can automate processes that normally require human intelligence. Like a self-driving car, even though a normal human is needed to drive, we can teach an AI system how to do this task using the methods we talked about earlier. So you understand, don't you? Many things that our mind uses can be replaced using systems like this. So I think you got some idea about artificial intelligence from this video. And I'm also very grateful to everyone who stayed with this video. Thank you very much.